This question is from GATE 2014 Mechanical Engineering paper, set 3, question number 31. A body of mass m, 10 kg is initially stationary on a 45-degree inclined plane as shown in the figure. The coefficient of dynamic friction between the body and the plane is 0.5. The body slides down and attains a velocity of 20 meter per second. The distance travelled in meter by the body along the plane is dash. Let's see how will we solve this. Since this mass is sliding down, its weight is going to act vertically downward. This weight will be nothing but m into g, where g is the acceleration due to gravity. Now we can form the components of weight. One is in the direction of the motion, that is downward, which will be mg cos theta, and another one which will be perpendicular to the surface, that is mg sin theta. Because angle between the surface and the horizontal being 45 degree, we know that this angle is also 45 degree, since this triangle is a right angle triangle. Now, when the body slides down, there will be friction acting on the body because of a normal reaction. Let this normal reaction be n. This normal reaction will be equal to mg sin theta because of the vertical equilibrium. For the body to continue to slide down on the surface, we'll need to have the net force perpendicular to the surface as 0. That is why we have the first result as normal reaction n is mg sin theta. Therefore, the frictional force that will oppose the motion will be mu mg sin theta. This is nothing but the frictional force opposing the motion, this F. Now we can write the equilibrium equation considering local x-axis to be along the surface while y-axis to be perpendicular to the surface. Now using Newton's second law of motion, we have sum of all external forces will be equal to inertia force, which is nothing but mass into the acceleration of the body. So let's substitute. Sum of all external forces will give us mg cos theta being in the positive side. We have mg cos theta. This is in the negative direction. Minus mu mg sin theta will be equal to mass is the same, so capital M into the acceleration. From this equation we can cancel out mass from all terms. What we are left with is g cos theta. This cos theta is nothing but cos 45 degree, and cos 45 degree is 1 by root 2. So we have g by root 2 minus mu is 0.5, which is nothing but 1 by 2. So g by 2 root 2, 1 by 2 into 1 by root 2, 1 by 2 root 2 is equal to the acceleration. By substituting the value of g, we have value of acceleration is 3.468 meter per second square. Let's go ahead and find out the displacement s that we need to find. So we'll use here the equation of motion that relates final velocity v square will be equal to initial velocity u square plus 2 times acceleration into displacement. This is the appropriate equation that contains our unknown displacement. We know the acceleration of the body, we know the final velocity. Initial velocity will be 0 because it started from rest. Let's substitute these values and find out the final answer. So we have v as 20 square is equal to 0 square plus 2 into 3.468 into s. This gives us s is equal to 20 square is 400 divided by 2 into 3.468. This gives us the answer as 57.67 meters. Let's go back and fill in the answer. Distance travelled by the body along the plane is 57.67 meter. To learn more about friction, you can refer to the NPTEL video Lecture 19, Friction 2 from the course Engineering Mechanics. This course is being taught by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.